So in part B, we have two different pulleys now. In the first scenario, we have the same solid disk as we were using in part A. However, in part 2, we have a hoop, which has the same mass and radius r. Each pulley has a lightweight string, and they're both being pulled with the same force. They're being pulled for some time interval delta t. And after this time, the change in angular momentum of the disk is equal to the change in angular momentum of the hoop, but the change in rotational kinetic energy of the disk is greater than that of the hoop. And we need to explain why this is. So firstly, what we need to note is that the torque on both hoops is the same. Hoops is the same, as the torque only depends on the force that is pulling these strings and the radius at which they are pulling. And therefore, our torque times delta t, since torque is going to be the same for both, delta t is also the same for both. So this is equal to delta L, will be the same for both hoops. So this is why their change in angular momentum will be the same. However, the moment of inertia are not the same. And the reason they're not the same is that since they're the same mass, moment of inertia depends on kind of how mass is distributed around the axis. And what we see is that for scenario 2, all of the mass is distributed very far away from our axis of rotation, and therefore the moment of inertia for the second case will be larger than for the first case. Because in the first case, we also have a lot of mass that is close to the axis, whereas we don't have that in scenario 2. So what we can then say is that since their change in angular momentum will be the same, their angular velocity will be different. So angular velocity will be different. And since we know that the rotational kinetic energy is 1/2 moment of inertia times angular speed squared, we see that the angular speed is very important for the rotational kinetic energy, which means that the disks, we can say that the rotational kinetic energy of the solid disk will have to be larger than the rotational kinetic energy of the hoop. And again, it's because their moment of inertia are different, whereas the angular momentum change is going to be the same. So moment of inertia times angular speed will have to be the same for both blocks. And since their moment of inertia are different, their angular speeds will also have to be different. And so these are the key points that we really need to include here to form a coherent paragraph.